So far, we've been focused pretty much exclusively on working with the visual layout editor, the outline window, and the properties window for building our graphical user interface. However, there are times when you're going to need to look at the actual XML that represents a layout, or as many programmers like to do, you may prefer to simply work directly in the XML representation of a layout. So here we have the reformatted code presented to you on the screen. I did the formatting of this code, but there is a formatting capability in the source menu here for Eclipse that will apply a standard format for XML if you're in an XML document, or a standard format for Java if you're in a Java code document. The thing you need to know is that you can configure how that formatting works by going to the window menu and using the preferences capabilities built into Eclipse. So for example, if you have certain code conventions that are required by your company or institution, you could configure Eclipse to use those as the guidelines for how the code should be formatted. And once you set that in Eclipse and then use the source format capability, it will use whatever you've configured through the preferences. Now, in this case, I've gone and reformatted this code by hand, and I want to talk to you about the different features of this XML document. So when we first replaced main.xml, which was originally containing a linear layout, with this new one containing a relative layout, it generated the start and end tags for our relative layout. And in the start tag, it generated this highlighted portion and the closing right angle bracket. The other pieces were added when we started interacting with the relative layout using the visual design tools. Now, this first XML ns:\Android attribute is required in every Android XML layout file, and this was inserted automatically for us when the IDE created the new version of main.xml per our instructions. The other things that were also added in by default were to say that the root layout should have a layout width that matches the parent and a layout height that matches the parent. And that's basically saying that the layout should take up all available width and height space within its parent. Now, in the case of the root element of a layout, the parent, quote unquote, is the screen of the device itself. So whatever amount of client area is available to our app, this layout is going to occupy that amount of space. At line 9, we have two other attributes that were specified as we edited this relative layout in the outline and properties windows. So the Android ID that we created is specified here. Welcome relative layout is the name of that component. And remember, we hard-coded white as the background color for this particular layout. And by the way, the white value, it turns out that Android has a bunch of predefined colors, and we'll start showing you how to use those in a subsequent app. And in addition, with color, just like with strings, you can take those color values and separate them out into resource files so that it's easier to change colors throughout your app. So for example, if we had hard-coded white as the color of a whole bunch of different controls within the app, and at some point we wanted to change everything that was white to be neon blue or something like that, then we would have to go through, find every occurrence where we hard-coded that value and change it, and we might miss some along the way. So instead, what we can do is define a color resource that defines the value of the color. Then we can take that color resource and use it throughout our code, and anytime we want to change that one color, we just redefine the value of the resource in an XML file, and it gets picked up automatically by everything else throughout the app. And we'll start to do that more in subsequent examples. The next thing we have here is our text view, and the text view has a bunch of different properties that are specified. The Android layout width and height were auto-generated for us. We didn't explicitly set those in the code. Notice they're both set to wrap content, and that basically means this text view will take only as much width and height as it needs to display the text that you see on the screen. The Android text attribute we specified as a string resource. Anytime you see an @ sign inside a double quoted string in the XML, that means we're accessing some sort of resource. Some of the types of resources that we have are ID resources, string resources, drawable resources, color resources, which we'll see in subsequent examples as well. So there's lots of different types of resources that we can access from XML files and use in our code. Next, we have the text size attribute, which remember we set to 40 SP for scale independent pixels, which is a similar to DP for density independent pixels, but again, scale independent pixels are going to also be factored by the default font size on the user's device. We have an ID attribute for the text view, indicating that it will be named Welcome Text View. We explicitly set its color to blue, and we explicitly set its style to bold, so you see the text color and text style properties. We also told it to center in its layout horizontally, and within the text view itself, we use the gravity property to indicate that the text should be centered inside the text view as well. And then finally, we set a margin top for the layout of 10 dp, which is going to allow us to make sure there's a little bit of gap space between the top of the text view and the top of the layout in which the text view appears. Next, we had the first of our two image views, and you can see that the layout height and the layout width were automatically set for us to wrap content. So again, these will only be as big as they need to be to display the actual image. The ID for this first one was Droid Image View. We told it to center horizontally in its layout. We also indicated that the source of that image view, that is the image that we want to display, is a drawable resource called Android. And that Android name was created for us based on the fact that the file, android.png, started with the word Android before the file name extension. So all that was auto-generated for us. At line 23, we can see that the layout below attribute was set for the image view, and this is where we're now using the relative layout capabilities. When you're in a relative layout, then the layout below attribute will be exposed, and we can then say which control we should lay this control out below. So by saying layout below at ID welcome text view, that means that this image view will appear below the text view. If I were to change this to say instead bug image view, which is the next one down, then this control would appear underneath the bug image view. And so you can change the relative positioning of these controls with respect to other controls. Now, separately, we have the last image view down here. Again, its layout, width, and height were set to wrap content. We've got its bug image view ID. This one's source is the drawable object called bug. And remember, by using drawable resources here, if we're working on different screen sizes and different resolutions and different pixel densities, and we provide various versions of these images in the different drawable folders, the app will automatically grab the most appropriate version of the image for the current screen size and pixel density. And if one is not available, it will scale another one of the images to the appropriate size automatically. We also have the layout below indicating that this should be below the droid image view, and the layout center horizontal set to true to force this to be centered in the relative layout. So at this point, we've seen all of the code in this XML layout. The last thing I want to show you is going back over to the auto-generated piece here. You'll see within the gen folder in our package is a new file that was generated for us called r.java. And within this file, these are all the resources that were created in our app. So this class called R, which means resource, was auto-generated for us, and it has a bunch of nested public final static classes, one of which is called drawable, and each of the different drawables that I created has its own hexadecimal representation as a value here. You can see these are all static integers, final integers that are being created along the way. For each of the IDs that I specified, it creates a corresponding integer ID value with the name that we specified. For the layout itself, because the layout file was called main, it creates the main integer that represents the main layout. If I had multiple layouts, each one would get its own name. And then for my string resources as well, we can see that we have app name, hello, and welcome. app name and hello were created for us by the IDE when we first set up the welcome app, and the last one was created at the time that we built the new welcome string. Notice it says at the top of this, by the way, that this is an auto-generated file and we should not modify it. If you modify this, you could actually break other aspects of your code. So you never want to touch this file directly. The main reason I'm showing it to you here is just to indicate that, number one, the R file exists, the r.java file exists, but more importantly, every single resource you use in an Android app gets an integer value associated with it, a unique integer value, I should say, associated with it. And these unique integer values can be used from Java code to look up the appropriate control or resource and then manipulate that resource programmatically. And we will be taking advantage of these various IDs in later apps so that we can programmatically control and interact with various GUI components on the screen.